We are starting a new chapter, and some of you might be happy to know that this chapter doesn't really involve graphing. So we're going to take a break from that. We are going to talk about exponents. So to write and simplify expressions involving exponents. Get our objective down. We'll do the warm-ups on the next slide. All right, let's get into these warm-ups. We are asked to evaluate, which just means that we're doing whatever operation the problem asks us to do. What operation do all of our warm-ups involve? Multiplication. So on the first warm-up, we're taking 3 times 3. Everyone should know that that is 9. On number 2, -1 times -1 is a positive 1.
8.
On number 3, 2 times 2 times 2, I agree, is 8. 2 times 2 is 4, then times another 2. That's how we get the 8. On number 4, 16 times 4 is... Anybody get it? What is it? 64. Questions about the warm-ups? Okay, many of you are probably already somewhat familiar with exponents. Exponents indicate repeated multiplication. So any of these warm-up problems could have been written with an exponent instead. So, we're using 5 just as an example in these notes. Really, 5 could be any number or any variable. The first power of 5, we would write 5 with a little 1, kind of in the top right corner by it. And we would read it as 5 to the first power. This should be going in your notes. The second power of 5, 5 with a little 2 in the exponent position. You could say it's 5 to the second power, or we say it's 5 squared. I'm sure you're getting the hang of what these look like by now. 5 to the third power, or 5 cubed. 5 to the fourth power. Doesn't have a special name otherwise. The diagram down below, which is already printed in your notes for you, shows us the parts of a power. So the power is the whole thing, a base with its exponent. The base is the number or variable that's getting repeated. The exponent tells us how many times we are repeating or multiplying the base to itself. So this one says b to the 8th power. That means we've got b multiplied to itself a total of 8 times. Write each expression in exponential form. So exponential form means using an exponent. 6 to the 4th power, I would agree with. So it should be a big 6 as the base, a small 4 up on the corner as the exponent. Make sure I can tell the difference between your base and your exponent. It should not look like a 64. All right, number 2, a to the 6th power. There were 6 a's, so a to the 6th power. Number 3 gets a little bit tricky. You have to multiply the similar pieces together.
-6 and then p to the third power.
Okay. So I agree with the -6. You got to take -2 times 3. And then we look at the p's. How many p's do we have?
3.
3 of them. So that would be p to the third power.
And then q to the second.
And then we've got 2 q's. So q to the second power. What questions do we have about example 3? If this is a review or you already learned this before, that's great. Just accept it as what should be an easy lesson, easy homework, easy questions on a quiz or test.
Okay.
We ready to move on? All right, be careful when an expression contains both numbers and variables. For example, on 2y in parentheses cubed, that means that we are taking 2y multiplied to itself how many times?
3.
3 times. And if we were to multiply this out, 2 times 2 times 2 is 8. Y times y times y. Y
3.
cubed, or to the third power. Versus 2y cubed is different. Here we don't have the parentheses, so that means that the 3, the exponent, only belongs to the y. So this would just be 2 times y times y times y, which just goes back to being what it began out with, 2y cubed. So the parentheses make a really big difference on these. So make sure you're paying attention. Does the exponent belong to the number and the variable, or just part of it? We have questions about the difference between those situations. Okay, that's one of the biggest sources of errors in this chapter. Not paying attention to our parentheses. All right, example 4 asks us to evaluate x squared if x is equal to -5. So here we have to be careful how we write this. I usually, if I'm needing to plug something in, I like to use parentheses in place of the variable. Inside of those parentheses, I would put whatever I'm plugging in, which in this case would be the -5. This means that I'm taking -5 times what?
2.
Not times 2, Dominic.
-5.
Times -5. A -5 times a -5 is a positive 25. Notice that that is going to be different than if we weren't to use the parentheses. If you don't use the parentheses, you just have a negative sign out in front and 5 times 5, so your answer ends up being negative. So for this problem, this is what we wanted. We are squaring the -5. This is not what we wanted this time. If you're plugging in a negative number, make sure you're squaring the negative. Negative times a negative comes out positive. It's a very small difference, but it can make a big difference with your answer and whether or not you get it correct. Questions on this slide before we move on? Okay, we'll keep it moving. Next up, we've got a summary of the order of operations. If you've been in this class or an algebra class on this campus since the beginning of the year, you've reviewed order of operations. Okay, some people refer to it as PEMDAS, P-E-M-D-A-S. If you remember it best that way, that's fine. Some people have been changing that to be a little more clear that multiplication and division happen at the same time, and addition and subtraction happen at the same time. Okay, so first we simplify within grouping symbols. So our old school way, P stood for what? Parentheses. So in general, grouping symbols. Usually they look like parentheses, sometimes brackets. The E, of course, stood for exponents. M and D happening at the same time from left to right. Multiplication and division. A and S from left to right. Addition and subtraction. Okay, one of the new acronyms that has been taught for it is GEMMA. So grouping symbols, exponents, multiply and divide, add and subtract. So they group multiply, divide together, add and subtract together, so that people don't necessarily think multiplying has to come first or that adding has to come first. If you want to stick to PEMDAS because that's how you learned it, that's just fine. Make sure, though, that you don't necessarily always multiply before you divide or add before you subtract. Do it from left to right. Questions, concerns, need more time with this slide? Okay, on we go. We are asked to simplify these expressions, which means we have to follow our order of operations. Now, there's really only one operation to follow on 5A. What is it?
Exponents.
The exponents. Does the exponent belong to the 3, the negative, or both?
The 3.
Just the 3. So if it's not in parentheses, only the 3 is getting the exponent, which just means our answer would be a negative in the end. Okay, so you could think about it as negative 3 times 3 times 3 times 3. Whereas on letter B, when it's in the parentheses, this would be negative 3 times negative 3 times negative 3 times negative 3. Do we see the difference here with and without the parentheses? Okay, it's a fact we'll be emphasizing a lot. So on letter A, we know our answer will end up being negative. What is 3 times 3? 9. What's 9 times 9? 81. So we end up with negative 81.
Wait, the second, like right here.
Letter B?
Is that under B or is
Yep,
that
that's
A?
nope, that's under B.
Okay.
So I just kind of split that there. Okay, so letter B, I already expanded it to show how it was different from letter A. So this time a negative times a negative times a negative times a negative means my answer will come out positive. Negative times a negative is a positive. And then we have a positive times a positive, which is, of course, still positive. Questions about A or B? Okay. Split these up a little bit. On letter C, parentheses or grouping symbols come first. That's a plus sign, I think. 1 plus 5 is 6. 6 squared, which would mean 6 times
36.
6 is 36. Make sure that you don't just assume your exponent is times 2 or times the exponent. Make sure you're multiplying whatever your base is to itself. 6 squared is not going to be 12. It's another common mistake that gets made. On letter D, do we need to add first?
No.
No, because there are not
That's
parentheses.
5 times 5.
So we have 1 plus 5 times 5. 5 times 5 is?
25.
1 plus 25 is?
26.
Good. All right, number 6. Evaluate the quantity 2a plus b squared if a is equal to 3 and b is equal to negative 2. The first thing we do when we evaluate, does anybody remember what it is? We did practice evaluating in this class back in August also, for those of you that were with us. Oh, is yours different?
Yeah.
Oh, okay. We'll go with what's on your paper. I can edit this. Or I'll just add, no. We might do those as extra practice. I'll just put up the ones you have for now, and then maybe we'll look at those. So your number 6 is 4m cubed. And what is m going to equal? Okay. All right, my question remains the same, even though we're doing a slightly different problem. If we are asked to evaluate, what's the first thing we need to do? Do what? Good. Plug in the number. So substitute and then simplify are the steps to evaluate. So we are going to substitute negative 2 in for m. Yes, I highly recommend, actually on this problem it would really be required, to put parentheses where the m was before you plug in the number. Make sure that your parentheses only go where the variable was. Don't make them go around anything else. So when we do that, what is getting the exponent?
3.
The negative 2. Does the 4 get the exponent? No, because it wasn't in the parentheses with it. So this would be the same as 4 times negative 2 times negative 2 times negative 2. When we cube negative 2, what do we get?
8. No.
I almost agree with you.
I did an 8.
Negative times a negative times a negative comes out negative. 2 times 2 times 2 is?
And then this 8.
8. So negative 2 cubed is a negative 8. And then, yes, I heard somebody say when we multiply 4 times negative 8, we get negative 32. All right. Questions about 6 before we talk about 7? Okay, so 7 is just a little bit different. This time, they have parentheses around the 4m from the beginning. So our steps still remain the same. I'm going to rewrite the problem. Instead of an m, I'm going to use another little set of parentheses. And in for the m, we're substituting negative 2. On this problem, what's our first order of operation to do? The parentheses. Inside those parentheses, we are taking 4 times negative 2, which is negative 8. And then that gets cubed. So negative 8 times negative 8 times negative 8. What do we get? Negative 512 seems about right. Of course, that would probably be a little easier with a calculator. Do we have questions about examples 6 and 7? We're sure? Okay, we'll go on to your 8 and 9, and then I'll bring back those last two for a little extra practice. Find the area of each rectangle. Does anyone remember how to find the area of a rectangle in general? Okay, you could either talk about it as length times width or base times height. Either way is fine with me. You'll see it written both ways. So one edge multiplied by the other edge. So for number 8, the area would be represented by what times what? Careful. Good. 5y times 2y. And when we multiply those together, what do we end up with? 10y squared. Very good. So 5 times 2 times y times y. If we were to rearrange it, which is 10y squared. You don't have to write out this middle row that I wrote. That's just showing you how we could put like pieces next to each other. On number 9, what am I multiplying together to get my area? 4x times x, which would give me 4x squared. Very good. Now, if we had been given values for x or for y, then we could actually calculate the areas. Before we get into our homework worksheet, I am going to go back to these problems. I'll write them a little bit bigger. I would recommend getting them copied down in your margins somewhere. 2a plus b squared. A is equal to 3. B is equal to -2. Should have room off to the side or down below. On the front, off to the side, or at the top. This is another evaluate type of problem, but this one involves more steps than the ones that we did. We also have 2 variables that we have to plug in. I would still recommend putting parentheses wherever you had a variable before. So a parentheses where A was, parentheses where B was, but leave everything else the same. Inside the parentheses that I put for A, what number am I plugging in? 3. And for my parentheses for B, a -2. By my order of operations, where do I begin? Inside the parentheses. So inside the parentheses, I'm multiplying and I'm adding. Which one comes first? Multiplying. So the first thing we're going to do is take 2 times 3, which gives me 6. And then we're adding that -2. 6 plus -2 is plus 4. And then we still have that exponent outside the parentheses. 4 squared is 16. Questions about example 6? Well, 6 part 2, I guess. Or we could renumber it. Bonus problem 1. Anybody need more time with this problem before I bring back the other one? Okay. Then let's bring back the other problem. I'll write it a little bit bigger. Up above, we've got x minus y cubed, all divided by 2x plus y. X is equal to 2. Y is equal to 5. The first thing we want to do, of course, is plug in. So you could go through and put your blanks for the variables. Cubed divided by 2x plus y. Okay, in the blanks where there was an x, I will instead write a, what number? 2. Instead of putting a y, I will write a 5. Okay, let's do the top first. In the numerator, start inside your parentheses. 2 minus 5 is? Negative 3. Negative 3 cubed. What's 3 times 3 times 3? 27, so a negative times a negative makes that a negative 27. In my denominator, the first thing I need to do is what? 2 times 2 is 4. 4 plus 5 is 9. And now this will simplify to a negative 3. Questions, concerns about any of these problems? For sure?